So you are on page 1 of your notes. Yes. As we finished our last unit, we were looking at linear equations. We graph them. As we are looking at those, we are going to start this unit with graphing. This also goes back to Unit A when you had to solve equations. So today we're going to look at that when we have no solution when you solve an equation. When you have infinitely many. Remember, when you had no solution, what happened is usually you had a false statement. Like you had something like, you solved the equation and you got 4 equals 2. And if it was false, you said there was no solution. And in Unit A, when we solved and we had a true statement, something like 2 is equal to 2 or 0 equals 0, we said there was infinitely many. So we're going to explain in a linear system what that looks like. So as you are looking at your notes here, when you have 2 or more linear equations means they're going to make a line, that are used to model a situation using the same variable, we call that a system of linear equations. It says any ordered pair that works for all the equations is going to be our solution. So when we look at the solution point of these 2 graphs, today as you do your homework, we were looking at like where this ordered pair is. So like where is that point? And to me it looks like it's at 2, 1. I don't know if this graph is to scale, but it looks like it is. It looks like my y-intercept for this one is y. So if I was going to rewrite this equation, right? So if I was going to rewrite that in slope-intercept form, it looks like y equals negative x plus 3. Does this look like a y-intercept of 3 as you're getting ready for your test? Yeah. Slope of negative 1? Yeah. This equation, if I was going to rewrite it and solve for y, put it in slope-intercept form, I would have subtracted x first, and I would have had negative 2y, and then I divide everything by negative 2. 0 divided by negative 2 is still y-intercept of 0. And my new equation has a slope of y equals negative over negative would be 1/2 x. Does that look like 1/2 x? So my point of intersection here looks like it is over at 2, 1. And if I would replace those 2 numbers, the x and y in both equations, it should make both of them true. So it says the solution is found by the point of intersection on our graphs. Now, in the last unit, one of the things I talked about with key features that was going to be on the test, right, is will 2 lines intersect? They will always intersect if they don't have the same slope. Okay? So we're going to be looking at that in today's lesson as we look at these. So you're going to be asked to graph. So this is good practice for your slope-intercept, right? So we're going to graph this system. To solve it by graphing, you must graph each equation and find the point of intersection. These 2 are nice because they're both in slope-intercept form. The first one, we're going to start out, what's our start point or y-intercept? 0, 2. Right? That's my start. So you're always looking at the equations in slope-intercept form, and we can find our start point. The second equation is going to start at 0, negative 2, right? We're going to do the first one in pink up here. So when you're looking at that, so we're going to start at 0, 2. What was my slope for that first one? 1 over 1. So I'm going to keep going up 1 and over 1. And I would probably have you come and grab straight edges because, or actually someone in the front of the row grab straight edges for your whole row because you really need. We are now looking at graphing that second equation, and when I graph the second equation, I'm going to do mine in green. Yours is going to be in the same color. I'm going to look at my start point, which is that y-intercept, 0, negative 2. This time my slope happens to be positive 3 over 1. So I'm starting down at negative 2, and I'm counting up 3 and over 1. And I count up 3 and over 1. And what you are going to be doing is looking for the point of intersection. So again, now, you are going to take your straight edge, and you are going to draw that nice line. And we have arrows on the ends of both of those, so making sure you have that. And then we're looking for the point of intersection, which is located at 2, 4. So it says to solve the system by graphing, you must graph each equation, find the point of intersection. Sometimes the single brace is used to show a system. So kind of like our notation when we were doing sequences for the recursive formula, they always had that out front. Also, when we did our piecewise functions, you're going to start it like this. So, does 2, 4 work in both equations? So we're going to do a check. The first equation, y equals x plus 2. This is your x, right? This is your y. If I replace, so I go to the equation, and if I put in 4, is that equal to 2 plus 2? Yes. If I go to this second equation up here, and I replace 4, is 4 equal to 3 times 2 minus 2? 6 minus 2, yeah. So it has to work in both equations, so this is my answer 2, 4 when I look at that, okay? So the solution that they were looking at is that 2, 4 that we put over there. So we're going to take a look at the next page, which you're looking at some stories. And so when you look at the stories, if you are going to read for us, Helen, would you read, please?
Scientists studied the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount?
So if we are looking at this one, first thing we got to think about what are our variables. One variable is W, the weight, right? The other variable is going to be T, or our time. So we're looking at weight, and we are looking at time as you are writing. Some of you aren't writing. It'd be good if you write with us, so then later you don't have to worry about that. So when we look at this, we might think of the weight as almost like our y, and t is going to be time, which is our independent variable, right? That tells us when we're measuring. So when we look at that, that's the weight of our alligators. And this is the time, and we're talking about time in what time period did they tell us? In months. The other thing that's nice is that we know that this is per month, right? So that's like our rate of change. That's trying to tell us your what? Per month. That's our slope. That's like our M when we look at it. So we want to look at alligator 1 and alligator 2, and we want to write an equation. We know alligator 1, if you are looking at this. What do we know about alligator 1? Their weight started where?
4.
At 4. My board got kind of weird when we did this. So you're gonna see the box, but let's see, how can I do this better? Let's do this. All right. So as you look at this, we're gonna put the weight of alligator 1, and I might just put W sub 1. Why? Because it's alligator 1. Started at what weight? 4 plus the rate of change 1.5 x. You want to use x? Could you use y sub 1 here? Yes, that would work too, right? You could use y sub 1 equals 4 plus 1.5x. Would any of you prefer to write it in slope-intercept form so it's easier to graph? I mean, because some of you get mixed up if you don't have it as 1.5x plus 4. So is that the same equation? Yeah. Alligator 2, W2, or weight 2, or y sub 2, if we call it that, is going to be looking at, this alligator started at 6 pounds, right? And is growing at 1. So again, I could have 1x plus 6. And so we are now going to be looking at that point of intersection. So when we do this unit, we're going to start with graphing. So when you take a look at your graph, we want to put weight on the side, and you want to have time down here, right? So does yours already show that in yours? Yeah. So let's do our starting point. Start at 4, right? Does yours go by 2 also? Yeah. Okay. So if we are looking at that one, right? We are looking at that point of intersection that yours shows, which we would say our solution is for this one going to be 4, 10. So if we are looking at this, where do we think our answer is? We would say 4, 10 is the point of intersection, which means what? What does the 4 mean? 4 months.
And 10 pounds.
They weigh 10 pounds. Okay? So making sure that that makes sense to you. And if I plugged in 4 for my x here, 4 plus 6 gives me 10. 1.5 times 4 is going to give me 6. 6 plus 4 is 10 also. So it works for both. Okay? So if you look at a story situation. Your next one down is we are taking a look at this one. We want to, again, write a system of equations. So as we are reading this one, if you would read, please, Lizzie.
One satellite radio service charges $10 per month, plus an activation fee of $20. A second service charges $11 per month, plus an activation fee of $50. In what month was the cost of the service the same?
So when we take a look at our equations, we are looking at satellite system 1, which gives us information that says $10 a month, but an activation fee of $20. The second company charges $11 a month and starts at $15. What is the 15 and 20 in our equations? The y-intercept. And the 10 and the 11 are our slopes. So, could we write it this way with c being equal to 10n plus 20 and c equal to 11n plus 15? Hopefully that makes sense to you. Could you use y instead? Now the reason that they use cost is because on our graph we have cost. So could you have 10x plus 20? Same thing, right? A lot of times you'll notice that they use, like in this case for the number of months, they might even use m when you are looking at it. So this one's a little uglier to graph, right? I just want you to do a rough sketch of what you're going to see up here, because I think it's kind of ugly to graph, right? Aren't there start points on this graph really close to each other? And there are slopes also. So please put a point, if you would, over here at 570. Okay? Put a point there. And then on one graph, make sure you start it down here at 15 and the other one at 20. And use your straight edge and draw those lines. Your straight edge, you drew that. And you can see the solution here, and it's ugly to graph that one. We should come out with 570 for our solution. And the answer is to the question that we want to look at. So the question said, in what month was the cost of the service the same? We would say in the 5th month. And then one company charges more and one charges less, right? So when we look at that, the information to answer our question is after 5 months. So on this test, kind of like on that last test when we solved equations, okay, we're doing our notes right now, we're not doing that. We're going to have time for that. I'll show you in a few minutes, okay? So, leaving your answer like this when you finish the problem. All right, so 3 possibilities when we graph a linear system on the top of page 3. The first one, you get 2 parallel lines. They never intersect. Your answer is going to be no solution. If you have a no solution, that's when your lines are parallel. If the lines intersect, like we've just done on the last couple problems, if they intersect, that means that they had different slopes. You will have one solution. That one solution is going to look like x comma y. That is the one solution. It's an ordered pair where you know what x is and you know what y is. And then the last scenario is when you're going to have your infinitely many. And the infinitely many comes up when we are looking at the same line. So how do you get the same line? So the equations are written differently, but when you graph it, one line is right on top of the other one. So when we look at that, we have our possibility of no solution, one solution, get that point of intersection, or infinitely many solutions. So those are going to be your 3 possibilities in your homework tonight also, okay? So when you look at the next page down in your notes, you are asked to graph these. First one, it's beautiful, right? It's in slope-intercept form. Second one, not so nice. What do we have to do to graph it? It's in standard form. We want it in slope-intercept because it's so much easier. So we are going to do what? To get y by itself.
Subtract x.
Subtract x. So this is going back to our literal equations back in Unit A. Y equals, we have negative, if it helps you put negative 1x plus 5. Use your straight edge and graph these. Y equals negative 3x minus x. Check with your shoulder partner. When you do the second equation, again, you have to rewrite this equation. You have to get it into y equals, so you might add x to both sides. This morning it was interesting, I was helping someone with, they're preparing for the test, and they just decided to put 2y, and then on this side they just put negative x. You can't just put negative x and move the equal sign. You are getting rid of that x by adding that. X plus 2, and now you're going to divide everything by 2. So part of it goes back to rewriting your equations. The first one started at negative 3, went down 1 and over 1. The second equation started at 5. What happened to those two lines when you graphed it? Parallel. So, if you're asked to solve the system, you have to answer the question. And the question says to solve the system is what is your answer? And your answer is that for this one there is no solution. And the reason if I asked you is because you have parallel lines. Our lines never intersect. So when you have the same slope, they will never intersect. So now in that second one, right, we rewrote this equation to be 1. We had a slope of 1/2, right? So positive 1, slope up 1 and over 2. Look at how this equation is. It's exactly the same one. So when you go to graph that, right, what should I notice is that it's the same line. It's like one line on top of the other one. If you were looking at this one, could you have done x and y intercept in that first one instead of doing it? If you would have done x and y intercept, what you would have found was that your x-intercept is -2 and your y-intercept is 1, and it's still the exact same line. So if we are looking at our solution, when we look at our solution for this one, we're going to say that this one is infinitely many. So in your homework tonight, you're going to have one slide. So you'll have a point of intersection, one solution. You'll have no solution and infinitely many solutions. So I'm going to be handing out graph sheets. And you'll look at the start of these. So you're doing 11 to 37 odd. The answers are in the back. You want to make sure you're checking those as you're going through. When you do your graph paper, so I'm going to hand that out. So on your graph paper, you're going to make an individual graph. Put your computer away. We're not using that. You are not going onto the decimals calculator to do these. You are doing these by hand. Okay? You're actually going to use your graph paper that I'm handing out. And I'll get you to your book in just a minute because I'm going to have this up here. On your graph paper, please make sure you put your name. And then you would put on this one D1 because this is the assignment. You're going to put the page number, which is 367. And you are going to take and draw a nice coordinate grid. And you might have like 6 graphs on one page, right? What do I need? I would need for you to write the problem right on your graph paper. What do I mean by the problem? I mean the equation. Y equals 1/2 x plus 7, and y equals 3 over 2x plus 3. Someone said, I don't know how tall to make my graph, and some of you will put your graph way towards the top. What do I know the y-intercept is? 7 and 3. Do I need a lot below the graph on this one? So when I go to put number 11 on my paper, I might have it like this. Why? Because I want to go up to like 10 or 12. But I don't need to go down to -1, -2, right? Because my 2 y-intercepts are at 7 and 3. You are then going to go to those points, the 3 and the 7. You're going to graph your 2 lines, and you're going to tell me the point of intersection. So your 2 lines in this case are going to cross. You're going to tell me where that point is, okay? That's That's what I need to see on the graph paper when you do your assignment, okay? I would say you'll probably get 11, 13, 15, 17. This one, you're asked to graph it and check the solution, and 21, so we'll look at those two. And then as you look at this page, this is why I'm going to add on more graph paper. You got 23, 25, 27, 29, and go through number 33. So 31 and then 33, they're asking you to correct. So let's look at number 19 together and turn your graph paper over to the back. On the back of your graph paper, we're going to take a look at number 19. When you read number 19, by the end of this unit, you'll be doing a ton of these type of questions, but we haven't seen a lot like it. So it says the number of right-handed students in our math class is 9 times the number of left-handed. Since our variables are y and x when we're graphing, do you want the right-handed people to be x, or do you want the left-handed people to be x? And it doesn't matter. You just have to choose. So what do we want to choose?
Right-handed.
Right-handed is what? X. Left-handed is going to be y. You kind of have to decide what you're talking about. So on my back of my notebook paper, or on the back of the graph paper, number 19, I'm going to say x is equal to my right-handed. We want to identify what our variables are. So right-handed. And y is my left-handed. Next thing. It said the right-handed students is 9 times the number of left-handed. What does that look like? Which are there more of? There's more right-handed, right? So x equals what? 9 times the left-handed. If there's only one left-handed person, it's 9 right-handed then, right?
Yeah.
What does that look like? X equals 9y. Don't make it harder than you have to, right? So if you decided you wanted to switch these two around, because then it's almost in slope-intercept form, right? So if you wanted this to be your y and that to be x, then this would have been y equals 9x. Slope-intercept form, right? To me, if I'm looking at one and I'm trying to do the equation, I might go, this is my y and this is x. Why? Because it's now in slope-intercept form, and I can graph that really easily, right? What's my y-intercept? No, what's my y-intercept?
No.
Y equals 9x plus 0. 0 is my y-intercept. So now I have to do the second statement. The total number of students, because I always have to have 2 equations. The total number of students in class is 30. I only have left and right-handed people, right? We don't have people that can go both-handed. So that means x plus y equals 30. Now, you could probably figure this out. I agree. Some of these are very contrived problems in that solving this, you really don't need these equations. But this is what you want to graph, okay? Number 21, you want to write the equations kind of like that also, okay? I want to show you on the Desmos graphing calculator. So what you're going to be doing on Friday is you're going to be looking at putting in your equations into the Desmos calculator. So if I was looking at this current assignment and I wanted to put in y equals 2x and y equals negative 2x plus 8, if you are looking at the Desmos calculator, we're going to put y equals, and so we're going to have y, we're going to put equals, and was it negative 2x? 2x. 2x. So we're going to put y equals 2x, one equation. You're going to go to the second equation, and it was y equals negative 2x plus 8. So we're going to put in y equals, and we have our negative 2x plus 8. And what you are going to be asked to do with each of these tomorrow is you're going to go back to each equation and you're going to click on this setting button. And the setting says, do you want a table? Do you want to copy it? You're going to put in a table. So now this is our equation, right? Y is equal to, if we are looking at that, y equals 2x. And they give you all those points on there. What's nice about this table is that if you don't see a point of intersection, you can keep adding numbers to this table. So you could say, oh, I want to check when x is 5 or 10. Okay, we're not going to do that. Again, you're going to click on this equation tomorrow, on Friday when you look at it, and we are going to make a table with it. Because one of the things when you get into your upper level math classes is that you need to be able to find that point of intersection on a table also. And what you will notice here is that obviously over at 2, if we look at both of these, at 2 it's at 4 and at 2 it's at 4, which is this point here, 2, 4. So on Friday it's just